I am sent a project title on 3D IC packaging technology. Packaging is one of the important fabrication process in IC packaging. The purpose of the packaging is to provide the support and protection to the IC and its associated wire bonds in order to withstand induced stresses from mechanical or environmental condition. It also helps to dissipate the excessive heat generated by the switching function and prevent IC from the damages. There are four levels of microelectronics packaging. Level 1, the silicon chip to module, and level 2 the card level, and level 3 the card to board level, and level 4 is board to system level. The purpose of the 3D packaging is to increase the high level integration and the functional packaging into a small fab factor, and it became important for improving the performance in order to reduce the cost. So 3D packaging has two or more active electronic layers which can be electrically or vertically connected through the wires, conductive wires. So if it's known as 3D packaging saves space by stacking several chips on single packaging. This is known as system in packaging or chip stacks. It doesn't integrate the chips into the single circuit. 3D IC packaging may accommodate multiple heterogeneous dies such as logic circuits, memory circuits, analog, RF or MEMS circuits. So this is the roadmap of 3D integration with through whole silicon wires. The 3D technology was already originated in the early of 2006. The integrated circuit with CMOS sensor is the first thing. And the second, the MEMS, almost all the MEMS components, if we see that it is a 3D packaging. And when you go for the integrated circuits, pure integrated circuit without mechanical systems, some chips are RF, analog and power. This may be integrated. So it is that is started in the early of 2009. Later there was a very big development in stacked memories like DRAMs by stacking more number of layers, and then HBLD LED modules, and at present the full-fledged 3D IC has logic circuit, analog circuits, SOC or SIC packaging. Types of 3D packaging. 3D packaging is broadly classified into three categories: package based on chip stack, integrated circuit chip stack, then wafer level 3D integrated chips. So the 3D IC means it consists of that is very old technology which is started in the early of is a 40-year-old technology which has system in packaging, POP, package on packaging, package in packaging, which consists of the stacking of one layer over the layer. The emerging capability, the new technology is using through silicon wires. It means that the holes is made through the silicon chip itself, and a conductor is made to the next level where you can able to make 3D IC integrations. So this is another that is the diagram. It shows that the DRAM stacking, and which is very popular in the early of 2000, and then the ASIC with logical and DRAM to improve the there is capability, and heterogeneous packaging which consists of RF, flash circuit, DRAM, ASICs. Packaging based on chip level is stacking of various levels of chips, and finally the 3D electrical interconnects are made through the wires. So this will make the device very small, and it's useful for mobile application, mobile device application. That it involves a standard packaging technology. So this is a diagram which shows package based on the chip level, which has three different layers, which has various levels of stacks or kept one over the other. The electrical interconnects are separately made, or electrical interconnects are connected through the ball grid, that is ball grids, and the third diagram indicates that the integration of both 1 and 2. Next one is integrated 3D chip stacks. In this it uses standard IC packaging and wafer level packaging. It uses through silicon wires in order to interconnect the various levels of chips. This wires are being made by two techniques. One is using laser ablation or direct process, and the side holes are, when you want to make a through holes for inserting the conductor, the side holes has to be insulated. Then the various layers are connected using a thermocompressive bonds. A good form factor and best signal integrity is possible with this integrated 3D stacks. This cartoon indicates or illustrates the diagram of 3D integrated die stacks. Next one is wafer level 3D integrated chip. 3D wafer level integration represents the ultimate stage of 3D packaging. It also uses standard CMOS packaging techniques as well as back end of line techniques. So bonding of the various thin layers of wafers together, this integration involves IC representative heterogeneous technology, CMOS image sensors or optical devices or RF amplifiers. Hence it is a significant opportunity for extreme device miniaturization for handheld applications. Wafer level 3D integration chip is shown here. So different wafers, silicon wafers are bonded together with bonded interface by wafer to wafer itself. Next one is, this is a system integration with 2.5D and 3D IC packaging. So if you see the left hand side of the grid, you may see that various signal devices are there, which is arranged in 2 dimension, which has photo effects and other magnetic and nanomagnetic materials and various processing circuits. Along with that, thermal heat exchange circuits. On the right hand side, if you see that various sensors like MEMS devices, biosensors, antenna, RF circuits, all are integrated together. And at the bottom edge of the substrate, you may find that batteries, it accommodates the batteries. So finally, it should have a very good electrical interconnect as well as mechanical stability and reliability, then thermal protection of the circuits. So this is a mixed signal electrical circuits which uses 3D technology. Next, when you go for manufacturing technology, so there are 4 types of manufacturing technologies there. One is monolithic IC, the second one is wafer to wafer, third one is die to wafer, fourth one is die to die. In monolithic IC, it uses single wafer in which all the electronic circuits are fabricated. It is being partitioned with high power dissipating circuit and low power dissipating circuit, and it is being thinned bond and other things. Next, when you go for wafer to wafer, 2 or more wafers in which the circuits are fabricated using through silicon wires. The active layers, the layers are bonded, so that this will give a very good compact and very good IC techniques. So one of the disadvantages in the wafer to wafer technique is, even if one wafer one circuit fails, the entire IC may fail. That is one of the drawback of this. So die to wafer is in this 2 or more semiconductor wafers. Once the wafer is dies, the singulated dies are bonded one over the other. In this, this is wafer to wafer. As the wafer to thinning is creation or similar to the wafer to wafer bonding. Next one, die to die is, first is various circuits are fabricated in different dies. So the dies are the multiple dies are aligned and bonded together, so that the first die of a stacks and the entire stacks is made. So the entire die became a 3D IC that can be binned beforehand, so that it can be mixed and matched to optimize power consumption and performance. Then thermal management system in a IC packaging is very important factor. As we know that IC will dissipate heat. If you go on stacking, so even a single layer IC, if you dissipate an enormous amount of heat. As you go on stacking one over the other, there will be enormous amount of heat, and it requires a proper heat dissipating system. And for heat dissipating system, the circuit may fail. So for that, what we can provide is, so three ways we can able to provide. One is floor planning. In the floor planning, so first the die level you have to segregate. The die which dissipates large amount of heat should be kept near to the heat sink, and the die which dissipates less heat should be bottom. So the left hand side shows the different chip placement or floor plan, and then the right hand side shows the arrangement that high heat dissipating device is kept first and the low heat dissipating in the bottom layer. The next one is enhanced heat management system. In this, the copper wires are provided through the various dies. So the copper wires will absorb the heat from the various levels and dissipate to the environment. Then the third one is interlayer convection cooling. In this, the micro channel are being etched across the various stacks of the IC dices, through which the water is being that is passed to absorb the heat. This is a very effective cooling mechanism. The benefits of the IC 3D packaging is, it is lowest cost. It provides a lower cost because you are going to stack various components in one thing, and the 3D chip saves space. The interconnect lengths required to connect between the various dies are reduced, therefore it increases the high performance will be achieved. So the delay and other things are reduced. Then it will become very compact and it is capable of using for many mobile devices. The performance increases because since all the dies are kept together, the performance will be increased. There won't be any delay, and the production and time to the market is also very fast. And moreover, it saves 40 to 50% of the power than the traditional ICs. It is an emerging technology for integrating various types and functional devices with the 3D stacks. That is a major advantage of this. There is a lot of issues and challenges in 3D packaging. One is yield. First thing is, as I already told you that when you're going to stack one over the other, if there is a failure in one chip or one layer, then the entire thing is to be discarded. That is one of the challenges. Second thing is heat dissipation, so that to be properly dissipated. Otherwise, even if one layer produces a lot of heat, which will damage and cause a heat spot and which will damage the entire circuit. Third thing is design complexity. Design complexity, so a lot of simulating tools are available in order to that is, before going for the real fabrication, it is required to simulate the conditions. So 3D CAD tools are required. And the fourth one is TSV introduced to our head. So the through-hole making technology is again another overhead for this. And fifth one is testing. So testing, since circuits are partitioned at various circuit level, that is the dies are partitioned at various circuit level. So the testing at any phase is very important. And finally, if there is any failure in any one of the layer, it's very difficult to identify. Finally, the lack of standards. Since there are only few standards available for TSV based IC design, so the standard yet to be evolved. Finally, I conclude that 3D packaging is currently providing the same sort of benefits at the system level that Mosler has been told at transistor level. 3D IC with the TSV represents the major new trends in the semiconductor industry. They have complete power, performance, and form factor advantage in many applications basis as they are to escalate the cost. Further, the development of 3D wafer technology will necessary to maintain the rate of technological progress required for the health of the electronic industry. So, the 3D packaging brings a significant thermal management challenges along with a next solution when compared to the traditional chip and packaging cost configuration. So, these are the few web references which I followed. I hope this will be informative and useful. Thank you very much. 15 minutes.